Assalamu alaikum and hello. Today I would like to talk about why I believe Java deserves modern tooling. Okay, that's a bit of a bold statement and needs some explanation. But before that, a disclaimer. The opinions and views I share here are completely my own and don't represent those of my employer or any company I'm affiliated with. Now, all the technology information I talk about is based on my own experience and research, and things change fast in technology, so double check the details before making any decisions. And of course, this isn't professional or legal advice. Okay, who am I? So, my name's Anha. I have a master's in computer science. I'm a senior software engineer, and I'm passionate about open source software and Linux. So when it comes to code editors, broadly speaking, we can put them into two categories. On the one hand, we have lightweight text editors, and at the other end of the scale, we have full-fat IDEs. So the lightweight text editors are things like Vim, Emacs, and Visual Studio Code. And of course, in terms of full-fat IDEs, we're talking about your Eclipses, IntelliJs, and Android Studios. Now in this Venn diagram, you can see there's a bit of an overlap, and that is because over time, lightweight text editors have a lot of the features and functionality that were traditionally thought of as the realm of IDEs. The lightweight text editors are able to do these nowadays. And for some developers, they question or they have very fewer reasons to use a full-fat IDE simply because their lightweight text editors are able to fulfill all of the features and functionality that they require. And that's really the background and the context and the perspective I'm coming from. So when I say I believe that Java deserves modern tooling, I'm coming from the perspective of lightweight text editors and not full-fat IDEs. So if we look at build tools and how they're used in either lightweight text editors or in terms of IDEs, we see a pattern, and especially for Java as well. When it comes to build tools for the lightweight text editors, they are complete build tool chains and they are CLI first and CLI focused. So we're talking about things like Cargo for Rust, .NET Core for C Sharp, Python's UV, and other ones like that. And on the Java end, we're talking about build tools such as Ant, Maven, and Gradle. Of course, as I said, they're Java focused, and what that means is that developers don't typically deal with these build tools directly, and it's something that's done indirect. So they will use their IDEs, and under the hood, the IDEs will trigger and automate and run the build tools. Whereas in a lightweight text editor environment, developers will actually use the build tools directly. So this is why they are sort of a CLI first class citizen. So when I say what do I mean by an ideal complete tool chain and that CLI focus, as I mentioned? Well, the build tool does everything from project scaffolding, compiling, dependency managing, everything, all the way to even managing the language version itself that is installed. That's what an ideal tool chain is, and a lot of those ones in the previous slide they do all of this stuff. So a little bit of history in terms of how build tools certainly within the Java world, and this is a very simplified history. So initially, you can imagine, things were manually typed in the CLI to compile a Java code, and if you've got one or two files, that's not a problem. But of course, that's just not realistic. And as soon as you have a few files, then you do need to start automating things, and people were writing shell scripts and things like that. But of course, there's no standardization there because every single project and company would have its own set of shell scripts. And then fast forward a little bit further, Ant is the first ever build tool, like certainly for Java is Ant, and that starts to standardize things a little bit. It's still very much configuration based and manage, a lot of manual stuff that has to be done. And then fast forward to Maven. Maven comes along, and now we start to have DSL and DSLs for essentially the build pipeline. But the more important thing is not just any standardization, but also the ability to automate a lot of these things. For example, like dependency resolution. And then Gradle comes along, and as you can see in the graph, this graph is a representation of, if you imagine complexity, then as soon as Gradle hit, the complexity went through the roof. And the reason is because Gradle essentially shoehorned an entire language into the build pipeline, and that language being either Kotlin or Groovy. So, and this is where the complexity really goes up. But of course, that makes the build tool incredibly powerful because it can do almost anything. But whether we need that, that's another question. And so I started looking in this in terms of what are the existing solutions in terms of that CLI first complete complete tool chain. And I found a few different projects. So, for example, I found BLD and Jekka. They're not what I'm after, because they are essentially like Gradle, but just swapping out Groovy or Kotlin for Java instead. And there's another project called JBang, and that's interesting. But again, this is not a CLI complete tool chain. What that is essentially being the ability to do scripting, but using Java. So that's really what it's focused for. Now, I did find one project which is fairly new, called Velez. I'm sorry if I'm pronouncing that wrong, and it's only a month old. When I say month old, it's sort of last month, end of October, and yeah, it seems to be interesting. So if we zoom out a little bit and have a look at how all of these solutions are done, they follow a similar pattern in the sense that they are implemented in Java. So you have the application code in Java, and that of course depends on the JVM. And some of these tools and solutions, they wrap around Maven and Gradle because they call out to Maven or Gradle. Not all of them, of course. And Maven and Gradle itself, runs plugins, and the plugins eventually is the thing that does the actual work and speaks to the JDK. Like, for example, Java C and Jar and whatnot. Of course, some of these solutions, they have their own custom plugin system, and then those plugin systems eventually then call into Java. Now, I've put a dash line because Velez actually does something slightly different in the sense that it uses GraalVM and a native image in order to build and I put this in air quotes, a native binary, but it's not really a native binary in that sense, because it essentially has substrate VM, which you could think of it as like a mini JVM with all of the Java classes, which are AOT, which is ahead of time and compiled, and then linked to that runtime. And that runtime has its own garbage collector. So I was thinking, well, if we get rid of all of that complexity, what if we just had proper native application code that speaks directly to the JDK, to the Java C and the actual things that build Java projects and applications. And that's really what I was looking for, and I haven't been able to find that. So what I mean by that is something that is like Cargo essentially. It has no dependencies, fully self-contained, and something that's an end-to-end complete tool chain, and has to be CLI focused. And of course, I was looking for as little as possible configuration, which means it has to have really good default and just work out of the box. And I couldn't find anything like that in the solutions that I looked at. And of course, so that's why Project Grind was born. Now, Project Grind is something that I've been working on, and I've open sourced it under GPL3 license. Now, what I'll do is I'll drop a link in the description so you can have a look at my GitHub repo and have a look at that. So, of course, in order to build a build tool, I had to start from first principles. And when it comes to dependency management, it's obviously not everything, but it's a large chunk of a build tool. And when dealing with Java, you cannot really avoid POMs. Now, POMs, or project object modules, are something that Maven uses. And I said it's somewhat of a standard in the sense that most tools will have to interact with POMs somewhere. And POMs are interesting because they are essentially a DAG, which is a directed acyclic graph, because POMs reference other POMs. And obviously that has to be all of those have to be resolved and merged. And of course, there is an order of precedence that has to be computed, and that's typically known as an effective POM. This is something that Maven does. Now, of course, when you walk this complex graph, what invariably will happen is that you will get what is known as collisions. When we say collisions, we mean libraries with multiple different versions, because you cannot use the same library but multiple different versions of it. You have to pick a version. Now, what Maven does is called closest win. So what that means is, as it's walking that DAG, the closest, or the first one that it visits, it picks that as the winner and discards the other ones. And that's okay. I mean, that's certainly a strategy. Of course, most modern build tools don't do that. And in Grind, what I decided to do is I opted to go with what modern build tools do, which is to, if you have a collision, is to pick the latest version. So the latest version wins. Now, of course, you can't just use that strategy. You have to use that in lockstep with a lock file. And this is what modern build tools will do: is that they'll have a lock file. A lock file essentially is the frozen, when you've computed the dependencies, it's essentially a freeze of that, because the reason is if you rerun that again and another version has come out, then on the same project, two developers could end up having different dependencies. We don't want that. We want reproducibility, and so a lock file helps with that, because it locks down what was resolved at that time when the project was compiled. So, okay, right, that's a lot of theory, but the actual project itself has gone quite far. And as I mentioned, I will drop a link in the description. When you go there, you can have a look at the project. As I mentioned, it is under GPL 3, and quite a lot of things have been, a lot of the goals in terms of what I wanted to be done is completed. And so let's actually look at it. Let's actually, see it in action. I think it's, rather than going through all of the theory. So, okay. I have it installed on here. So this is Grind fully installed, and to install it, you simply you can go into the releases, pull it down, take down a copy, and then put it into your binary path. Now, apologies, but at the moment, the Grind only supports Linux and Mac. There isn't support for Windows at the moment, although you could potentially run it under WSL. And of course, it's open source, so if Windows compatibility is something that's important for you, then certainly, or contribution is certainly welcome. If we go back, so let's have a look. If we go back here, I'll make this a little bit larger so you can see. Okay, let's clear this screen. So I've got Grind installed. Now, as I mentioned, it's a complete tool chain. So what that means is, so in here we can run, Grind can actually handle. So if I do Grind Java current, it'll say yes, it's unable to detect any Java on this system. So because the Grind handles Java version management. So in this system, we have no Java installed at all. So one of the first things we're going to do is we're going to install, let's list. So if we do Java and list, let's list out all of the Java versions that are out there. So from all the way from version 8, we have version 25. Why not? Let's install Java version 25, and we can do that. So we can say Java grind. So we can say grind Java use 25. So what that's now going to do is it's going to go ahead and install it and set up everything for us, version 25 specifically. So that's what it's doing, because it's detected that we don't have version 25 installed, and it's going out and it has to detect which operating system we have, what CPU architecture we have, and it figures all that out, resolves all of that, and as you can see, it's now downloading that, and we get a little downloader counter. Of course, I don't have the fastest internet, so apologies. And if you bear with me, it's going to, because as I said, I don't have Java installed on this particular environment, and so I wanted to do it from scratch just to show that the actual tool will handle everything for us, because it is a complete tool chain. So we'll let that keep running. And as I mentioned, if we go back, as I mentioned, it's able to do quite a lot of things at the moment. There are a few things that are still in the works, specifically around the testing area. Although there is some experimental tests that's there, but let's have a look. It's nearly completed now. Okay. Right, so it's going to extract everything, and now it's completed. So what we'll have to do is we'll need to close this, and got another shell open. So if we now do grind Java, actually I might need to close this one as well. So if I close that and then if I open a new terminal, make that full screen. Okay, let's make the screen a little bit larger so it's easy to see. And the first thing we're going to do is create a new project. So we'll do something like grind.new. We put in the group ID, so something like com.example. And let's create a web-based echo server. So echo server. And so that's now created it. We can cd into that project. And we can actually run this project, compile it, build it, and run it in one go. And we can just say grind run, because the skeleton has actually added just a hello world. And yep, as we can see, it has emitted the hello world. It's compiled it, built it, and run it into the actual console. Now for the web application, we need a web server, and I like to use Javelin. It's a very lightweight web framework, but I like to use a very specific version. Now to add the dependencies is very easy. You just do grind add. And similar to the project, we need the group ID. So in Javelin's case, that's IO Javelin. We do / and then the artifact ID, which is Javelin. And then we do the @ symbol, because I'd like to use a slightly older version rather than the absolute latest, because the latest version, the syntax has changed and it's something that I'm unfamiliar with. So I want to pick 6.7.0. Now, if you don't put if you don't do version pinning, grind will automatically resolve the most recent version and pick that instead. So Kotlin itself Javelin actually I believe is written in Kotlin, and it depends on the Kotlin standard library. So we need that. So we'll do org.jetbrains.kotlin /kotlin-stdlib. And also we need a logger as well, so something like org.slf4j /slf4j-simple. Now hopefully that should be all of the dependencies that we need. Now it's going ahead and walking through all of that directed acyclic graph and making sure everything is fully resolved. It looks like it's done. It's pulled everything down that we need and all the transient dependencies that the dependencies need as well. So that's all been done. That's brilliant. Let's open up a code editor, Visual Studio Code in this case. It doesn't have to be obviously that one, but that's what I like to use. And let's make that full screen. So okay, let me close this. Now if we look at the directories, we see source, Java, com.example, and echo server. So very much following standard Java projects, the way that they are laid out. Now we need to import the Javelin library, so we'll just do import io.javelin.javelin. So we've got our Javelin there. Now let's create a web app object. So we'll say var web app equals a Javelin dot create, and what we'll do is put the first get handler in there. So we'll do ctx equals results hello world. I like to do like a little hello world because it just confirms that everything is actually working as expected. We will then build in the actual, we'll first demonstrate that it actually works, or we'll make sure it works before we go ahead and actually finalize the echo part of the functionality. So there we have everything there. Let's save that. And now let's try and build and compile this. So if we do grind run, does that work? Have we made any syntax errors? I'm not sure. No, it looks like it's correct. So as we can see, Javelin 6 has booted up, and we can see that it's listening on localhost 8080. So if we jump into our browser and go to localhost 8080, we can see hello world. So yes, clearly it has worked. This is brilliant. Okay, so let's stop this, and now let's actually sort of build our echo server. So what we'd like to do is we need to expand on expand on this function block here, or this closure. So let's remove that from here and put that there for now. And then what we need is the actual path parameter. So we'll just say var echo is equal to ctx.path param, and we want something like echo. So if we close that there, and we can define a path sort of variable there. So it will take that path parameter, put it into here, which is fine, whatever that value happens to be, and then we can just say hello world, you said something like, and then let's just add the echo here. So semicolon at the end of that. So that looks about right. Now let's compile this and run it, assuming we have not made any syntax or programming errors. So let's do compile and run in one go. Grind run. Let's see if that works. Okay, so it's compiling it, it's running it. Brilliant. It looks like that has worked. So let's go across and let's do something like / grind. Let's have a look. And it works. Our echo server is working. So hello world, you said grind, and we could do something else like foo. Let's see. Yeah, hello world, you said foo. So whatever path is in there, it will take that and echo that back. So okay, that's fine. Let's stop that server and clear the screen. Okay, that's fine. You might think, well, yeah, that was a very trivial application, but what can it handle something real as a real world project? So one way to test that is the famous pet clinic, which is done by the Spring Boot team, and you know that's a non-trivial application. And so what I did with grind, I used that as a test bench to see if we could actually compile it, and it turns out we can. So the way I did that was I used grind to bootstrap a new project, and then I just literally took the source code, the SR source folder, and then swapped it out in that new freshly created project. And then I went through the POM file of the pet clinic and just the top level dependencies, put that in and add that in. So rather than obviously we can grab that because I have that hosted on my GitHub account. So we can do git clone, and let's go ahead and grab that just to see. So do github.com/amhar. So this is my account, pet clinic application. So that's going to clone that down. So if we go into our pet clinic application, we can have a look and see, as I said, the actual source folder is what I took from the upstream pet clinic example and just literally swapped it out. So it's the exact code, all of that pet clinic application. So the first thing we need to do is we need to actually install all of the dependencies for the pet clinic, and it has over like 100 dependencies because it's a non-trivial application. So we can just do grind install, and you'll see that it's not resolving anything because it doesn't need to, because of the lock file. It's already pre-computed it and it's in the lock file, and it will pull down exactly the dependencies that it needs. So because as I said, it's about reproducibility. So that's why we have that lock file. So it's now using the lock file because it's detected that it's there, and it's not having to run that computation of building that effective POM again. And now it's pulling that down. So we'll let that pull down because obviously, as I said, the pet clinic application is a non-trivial application, so it has a lot of dependencies. And so, yep, okay, looks like it's done everything. Now, let's see if we can actually run this. So grind run. Let's go ahead. So now it's going to compile this, this fairly non-trivial application. It's pretty large, and it looks like it has booted up. So okay, let's. It's still booting up because it's a very heavy application, and yeah, so it's still booting up. I mean, it's not the smallest of applications. Now it looks like Tomcat has started on port 8080. Brilliant. So that means if we now go to port 8080, actually what I'll do is I'll close this tab, open a new tab into localhost port 8080, and there you go. So we have the pet clinic application. So if I make this smaller, back to 100%, we can see it's actually it's running this application perfectly fine. So even something as a non-trivial application it's able to do. So if we go back here, let's just stop this. Okay, that's pretty cool, and we can certainly compile it, and that's grand. But can we turn it into a fat jar or an uber jar, which is to bundle everything into a single jar? Because at the moment, it's whilst it's compiled everything, they're just actual raw classes. They're just raw classes sitting here, as we can see. All of if you go into each of these things, it's the actual raw class. It's not a jar file, but we can do that because grind has this new experimental bundle command that we can do. So we can just say grind bundle, and if we run this, it's now going to go ahead and create an Uber jar. So it's going ahead and now it's going through everything and compiling it down into a bundle, and now it's done that. So we can see 99 dependencies all merged and everything, all the classes and whatnot. So if we go into the build and have a look, we can see there the petclinic.jar is right there. And if we do ls-h, this petclinic jar file, this is everything in a jar, all completely bundled, and it's 146 megabytes because it's a non-trivial application and it has hundreds of dependencies, but it's packed. But can we run this? Can we actually run this? Does it work? And let's have a look. So if we do java-jar petclinic, does it boot up? And it's definitely running and booting up. So it does work in a non-trivial example, and it's doing exactly the same as before. And it's on Tomcat port 8080. So if we went back, I'll close that just to prove that that's not the one before. So we do localhost port 8080, and it runs. Okay, there's some few things that are missing, which is fine. This is probably to do with some properties that has not been injected in, which obviously in the development version it is. But anyway, with those things aside, it does prove even a non-trivial complex application grind is able to do that. Okay, that's fine. So maybe you're thinking, so if I go out of there, okay, so obviously we've seen that we can do a trivial application, we can do a non-trivial application, but could it do something like a Java FX project? Because that's a little bit more complicated. And it turns out, yes, grind can actually handle that, but we have to do that slightly different, and I'll explain in a moment. So let's first of all, let's clone an example that I have. So from my GitHub account, go to github.com and we go into my repository, my GitHub account. I have an example called HelloFX. So we'll clone that down, and if you go in there. Now, the thing with JavaFX, the dependencies are not quite straightforward because you have a lot of native DLLs or SO shared objects, binaries, and so the project has to be a little bit somewhat patched, I guess. You could use that word, but I've automated all of that. And one of the features that we have in grind is the task. So if we do grind task list, this will you're able to put in custom tasks that you can run, and they can essentially be any kind of, it's almost like bash script, really, any sort of bash shell scripting. And in this case, obviously, because we need to patch some of those dependencies, I've bundled that, and we have these custom tasks that can be run. I can do that. So here I've got one that says init JavaFX, and what that does is initialize a project to have all the correct dependencies and patching that's needed. So if we do grind task init JavaFX, now it'll go ahead and it's running that custom automation in order to patch this project. Now there's a slight bug in this particular build, but that has been fixed in the most recent build, where it's not actually streaming that output in the tasks, which is why we're not able to actually see what's happening. But behind the scene, it is actually downloading all of the correct, the correct dependencies and the native dependencies as well, and then putting them in the correct place for the project so that the project can run. So we'll let that go ahead, and it'll continue to do its stuff behind the scenes. And it looks like that's completed everything and done the cleanup as well for us. And so if we now do grind run, hopefully that should now have all the patched correct dependencies, set of JavaFX specific dependencies, which are not just jar files, but they are also native library, native DLLs or native SO objects, compiled objects. And now if we compile it, it should all link and everything and run. So if we do, it should compile and run it. So if we do grind run, and now it's compiling that project, and hopefully it should run. And yes, we have a full-on JavaFX, and this was just a silly little hello world thing that was done. But it just demonstrates, of course, that even something as complex as a JavaFX project, we're able to do that. Obviously, it's not in a fully standard way, I believe things like other heavy build tools go through and they use plugins and all sorts of things. But here we are doing that kind of directly with a little bit of automation, just using all of the standard features that are available right now. Now, of course, as I mentioned, this is an open source project, and yeah, it's still evolving. But even at this stage, so we're at sort of version 0.8, it seems to be possible to build certainly fully fledged non-trivial applications even at this stage. And of course, going forward, there'll be bugs and a lot of polishing I like to do. And that's all I wanted to talk about today. So if you found this useful, please do let me know. And as I mentioned, it is open source, and contributions are always welcome. So do have a look at the project. There will be a link, as I mentioned earlier. Have a look at that and let me know what you think. Okay, bye.